Welcome to amazing episode on Olympiad mathematics problem. Today we are trying to solve for the value of m in m power 9 plus m power 6 is equal to 36. For us to solve this, first thing we just have to break it down. And to break it down is very, very simple. What are we going to do? Recall that from the laws of exponent that we have that a to the power of m raised to power n is equals to a to the power of mn, right? So we can now write m to the power of 9 to be in powers of 3. That means m to the power of 3 raised to power 3, because 3 times 3 is still giving 9. Then same thing is applied to here. We are going to still apply this law. We write it as m to the power of 3 all squared is equal to 36. The reason for this is that 3 times 3 gives 9 and 3 times 2 gives 6. So we're having m to the power of 6, so nothing changed. So we now have to define terms. So we can say let y be equal to what? M to the power of 3. Okay? We'll now substitute back since we've gotten this form. So since we have m to be m power 3 to be y, that means we are having it to be y cubed because of this cube. This is m power 3 now. Then plus, this is now y again because it's m power 3, plus y squared is equal to 36. Okay? If you look at this, this is clearly a cubic function because of the highest power is what? 3. So we can now write it as bringing 36 to both sides. That is subtracting 36 to both sides. We have y to the power of 3 plus y squared minus 36 equal to 0. Okay? So since we have this now, it is very easy to do. Now we are going to factor this cubic function. So first we do a little trial and error. Plug in the value of y to be 0 to know whether all the terms will be 0. Remember, we are trying to solve for 3 possible values of the y first. So what we are going to have is that when we plug to be 0, we have it as at y equal to 0, we are having it as 0 cubed is 0 plus y 0 squared is 0 minus 36. And this is not equal to what? 0. So this is not a factor. So we look at y equal to 1. That will give us 1 cubed is 1 plus 1 squared is 1 minus 36. And this is not also equal to what? 0. Okay? Then we'll look at y equal to 1. You can see that if you put 2 cubed is 8, 2 squared is 4, minus 36, and this is not equal to what? 0. So let's look at 3. When y equal to 3, for instance, you can now see that 3 cubed is 27, plus 3 squared is 9, minus 36, and this is actually equal to what? 0. So y equal to 3 is a factor. So since we are using y equal to 3, to make it a factor, since we picked y is equal to 3, that means we subtract 3 from both sides, telling us that y minus 3 is equals to 0. So this y minus 3 is a factor of this cubic function we have here. So since we have this, we are having y cubed plus y squared minus 36 is equals to 0. So let's actually expand the middle term. So I can suggest a factor. I can choose a factor of minus 3 and 4 so that we can still get the coefficient 1, because if we add them together, we are still having 1. So we are having y cubed minus 3y squared plus 4y squared minus 36 equal to 0. Okay, at this, I will now factor the first term. If I factor out the first term, I can actually factor out a common term, which is y squared. We have it as y squared into what's remaining here, y, okay, then minus 3 into already existing term plus 4y squared minus 36 equal to, we have that y squared into y minus 3, then plus 4y squared minus 36 is what? 0. So at this stage, let's just add minus 12t and 12t. When we add them together, it's actually 0. So let's add it here. So we have y squared into y minus 3, then plus 4y squared minus 12t, okay? Then minus 12y, then plus 12y minus 36 equal to 0. So at this point, we can now factor out here the common term. So we have it as y squared into y minus 3, okay? Then the common term here is 4y. So if I factor out plus 4y, what am I left with? I'm left with what? Y minus 3. Then at this point, what am I going to factor out? I'll factor out 12y. So I'll factor out plus 12, just plus 12. I'm left with y minus 3 equal to 0. What is common here? Y minus 3 is here, y minus 3 is here, y minus 3 is here. By factoring, what do we observe? We observe that we are having, since this is common, we have y minus 3, which is the common term, into, we are having it as y squared, the next term plus 4y, the next term is plus 12, is equal to 0. So let's look at this. This is now a quadratic function. Can we actually solve this? Let's try. Let's check whether, to solve this now, we observe one thing. We know that in quadratic, we have ax squared plus bx plus c. The reason for this is that there is no two numbers that multiplies to get 12 and adds to get what? 4. So it's not factorizable. So you can see we have this. So let's check whether this particular root of this particular quadratic function is actually greater than 0, so that we won't get a complex root. It says that is equals to b squared minus 4ac. Okay, a is the coefficient. A is the coefficient of the variable 1. b is the middle term, which is 4. Okay, and c is the last term, which is 12. So if you try this now, you can see that we are having what? B squared is 4 squared minus 4 times A is 1, C is 12. And that will give us 4 squared is 16, 16 minus 4 times 1 is 4, times this is 48. And if you minus, you are having a negative what? Root, which is what? Which is less than what? 0. So since this is less than 0, this particular term here will be giving us a complex root, and that's not what we want. So the only solution we have is that y minus 3 is the only possible solutions that we have, okay? And that's equal to what? 0. That means that y is equal to 3, okay? When we actually add 3 to both sides, okay? So the next thing, you recall what we defined to be our y. We said that our y is m cubed, okay? So since y is m cubed, we have it that m cubed is equals to what? 3. So for us to get the value of m, we take the cube root of both sides, the cube root of both sides. If you take the cube root of both sides, you see that m is equals to what? m is equals to the cube root of 3. And that's the required solution. Okay?